Okay guys, we are moving right on. We're gonna kind of go in a weird order like we have been for the rest of the chapter. So yesterday we did 10.3 and 10.5. We're skipping 10.6 for now, we'll go back to that later. We're gonna do 10.7 instead because it is like a direct continuation of what we did yesterday. So basically what we're gonna be doing today is we're gonna be finding shaded area, okay? So you'll notice like the inside shape is exactly what you learned how to do yesterday. All right, so before we can do shaded area, we need to know the area of a circle. If a circle has an area of a square units and a radius that we're going to call r, then area equals pi r squared. That is your area formula for a circle. Again, r is the radius. Okay, so here's our first example. If you are having a party and you want to make a cake, you have a Pillsbury cake mix that makes one 10-inch cake, and you have a Betty Crocker cake mix that makes two 5-inch cakes. You want to feed the most people. Which cake mix should you use? And we're going to assume that the cakes are the same thickness. Okay, so you kind of have two choices here on how to solve this problem. You can find the area of one 10-inch cake, and then you can find the area of two 5-inch cakes and see which one is more. Or you can simply draw a picture, and that's what I'm going to do. So I'm going to draw a 10-inch cake. When we say a cake is a 10-inch cake, we are meaning that the diameter is 10 inches. So all across, the diameter is 10 inches. Okay, so there's our 10-inch cake. That means the radius is 5, and the radius is 5. So then a 5-inch cake means the diameter is 5. So this is the diameter of our 5-inch cake. So the 5-inch cake looks something like that. Okay, and then another 5-inch cake is over here. There it is. Okay. My circles are not perfect, but they are good enough. They look like circles, and I can see that the 10-inch cake gives us all of this extra area. Okay? Again, my circles are not perfect, but they are close enough to believe the picture, to believe that this 10-inch cake would fit both 5-inch cakes inside of it. Okay? So you should make the 10-inch cake because it'll serve more people. Okay? Now, I do want to warn you against using this method if the circles would overlap at all. So here's what I mean by that. There's a problem in your homework where you're going to have a 9-inch cake and then 9 3-inch cakes. So a 9-inch cake means all the way across is 9 inches. So I could fit 3 3-inch cakes around there. So I could fit a 3-inch cake here, I could fit a 3-inch cake here, I could fit a 3-inch cake here. And then I could do the same thing vertically, a 3-inch cake and a 3-inch cake. Okay? So right now I have 1, 2, 3, 4, 5 3-inch cakes. If I try to fill in the other 4, notice that things start to overlap, and I have no idea if these overlapped sections are greater than, smaller than, or equal to these blank sections. So in a problem like this, where you have a 9-inch cake and then 9 3-inch cakes, you would not want to draw a picture because I don't know if the overlaps and the blank spaces are equal or if one's greater than the other. So do not draw a picture in this situation. Okay, next problem, example 2. A caterer has a 48-inch diameter table that is 34 inches tall. She wants to make a tablecloth that will touch the floor. Find the area of the tablecloth in square yards. And notice that they gave me inches and then we want yards at the end. So we are going to have to change units at the end of the problem. Okay, so what we know right now is that, so this is the table. This is like a bird's eye view of the table. So this is the top of the table. And then the tablecloth is going to be bigger than the table because we want it to hang down to the floor. So table is 48 inches all the way across. Okay, so that's 24 inches here, 24 inches here. And then we want the tablecloth to hit the floor, and the table is 34 inches tall. So we need an extra 34 inches hanging off the table on both sides. Okay, so to find the area of this big tablecloth, we're going to do pi r squared. Okay, our radius is 58 inches. Okay, I'm going to go ahead and do 58 squared. And I get 3,364, and then I'll put pi next to it. Okay, that is my area of the tablecloth, and that's in inches squared, but we want the answer in yards squared. Okay, so we're going to take 3,364 pi inches squared, and we're going to convert that to yards squared. Okay, this is like, if you do this in science, it's called dimensional analysis. So we want to cancel out the inches squared. So I'm going to put inches on the bottom. I want my answer to be in yards squared, so I'm going to do yards on the top. And I know that there are 36 inches for every 1 yard. 1 yard, 36 inches, those are the same thing. Whenever I put something on top of itself, this fraction is equal to 1. Okay, so it is not changing the value of this number. It is just changing the appearance, because I am simply multiplying by 1. Okay? Now, I have to do that twice because I need, this inch will only cancel with one of these inches. Okay, so I have to do this again. Okay, inches squared will cancel with inches squared. Okay, so my unit now is yards squared. Okay, and I have to put these numbers into my calculator, and I'm just going to put them all in at once. So I'm going to go 3,364 pi divided by 36 divided by 36. Or you can go like this. You can hit enter. Okay, there's your number. Okay, and then you're going to divide that by 36 and hit enter, and you're going to divide by 36 again and hit enter. So we get approximately 8.2 yards squared. That is your final answer. Approximately 8.2 yards squared. Okay, let's flip over to the back. On the back, all of these problems are shaded area problems. So to find the shaded area, we are going to take the circle, and we're going to subtract the triangle because the triangle is not shaded. Okay? Remember, to find the area of a circle, it's pi r squared. To find the area of the triangle, which is equilateral, you can do 1/2 base times height because that works for any triangle. Or you could do 1/2 PA since this is equilateral or regular. So I'm going to do 1/2 PA. Okay, so let's take a look at our picture. The radius of the circle is 4 meters. Okay, I currently do not know the perimeter of my triangle, and I also do not know the apothem of my triangle. So I will just leave those blank for now, and I'll fill them in a second. To fill those in, I'm going to need to come over here and make my right triangle. And I'm going to have to figure out this angle. It's going to be 360 divided by 6, because I can fit 6 of these right triangles inside this big triangle. 2 on every side. Okay, so this is a 30, 60, 90 triangle. This is our 2n. So this is our n, and this is our n square root 3. Okay, that means the entire side length here is 4 radical 3. To find the perimeter then, take that side length and multiply it by the 3 sides. So we end up with 12 square root 3 meters. And the apothem is 2 meters. Okay, let me zoom in a little bit on this. Okay, so 4 squared is 16 pi meters squared. Okay, the 1/2 and the 2 cancel out, so we just have 12 square root 3. Meters times meters is meters squared. This is our exact answer. There's nothing I can do to simplify that. So that's my exact answer, and that is approximately 16 pi minus, in parentheses, 12 square root 3. Close up the 3, close up the first set of parentheses, and hit enter. And we get approximately 29.5 meters squared. Okay, we're going to move on to the next one. Okay, on this one, to find shaded area, we are going to do circle minus hexagon, because again, the hexagon is not shaded. So that's pi r squared for the circle, and then 1/2 pi for the hexagon. Okay, we currently do not know the radius of our circle. I'm going to draw it in, and I'll figure out what that is here in a minute. Right now, I'll just leave it blank. I currently don't know my perimeter, but I do know my apothem is 12 meters. So I'll fill that in for apothem. Okay, we're going to come over here, and we're going to figure out this angle. This time, it'll be 360 divided by 12, because I can fit 12 of these right triangles inside the hexagon. 2 on every side. Okay, so this is a 30, 60, 90 triangle, and this is your n square root 3. So your n is 4 square root 3, and this is 8 square root 3. Okay, so the radius is 8 square root 3. This side length is also 8 square root 3. And if I take that side length and multiply it by the 6 sides, I get 48 square root 3 for the perimeter. Okay, 8 square root 3 squared. I want to make sure if you're using your calculator for that, that you enter it correctly. You have to use parentheses. 8 square root 3, close up the 3, close up the original set of parentheses, and then square it, because you need to make sure you are squaring the entire thing. Okay, and we get 192 pi meters squared minus 0.5 times 48 times 12. And we get 288 square root 3. Meters times meters is meters squared. So this is the exact answer. That's as simplified as it gets. And then we can approximate that. So 192 pi minus, in parentheses, 288 square root 3. Oops. Close it up, so that you're subtracting the entire thing, and then hit enter. We get approximately 104.4 meters squared. All right, and the last one, shaded area, is the circle minus the triangle. You do need to be careful this time because our triangle is not an equilateral triangle. It's not 60, 60, 60. So for the triangle, I have to do 1/2 base times height. I cannot do 1/2 PA. 1/2 PA only works if the shape is regular. Okay, so it tells us that the circle has a radius of 6. So plug that in for radius. Okay, and then for the triangle, remember any side of a triangle can be your base. You get to choose. But your base and your height do have to make a right angle. I am not going to make this my base because I don't know what this height is that would go with it. Instead, I'm going to complete this 30, 60, 90 triangle. The hypotenuse is 12. That means the short leg is 6. and the long length is 6 square root 3. I'm going to choose 6 to be my base because there's already a height that's perpendicular to that base. So my height's going to be 6 square root 3. So I get 36 pi minus 18 square root 3. Okay, this is just units squared. They didn't give us a unit. So we would say units squared. And that's approximately 81.9 units squared. Okay, and that concludes the notes for today.